Hello everyone, today is November 30, 2025 and it's the last day of November. So I can't think of a better way to end the month by doing another coding exercise. So today I'm gonna try to solve this LeetCode 104 maximum depth of binary tree is an easy problem. So I didn't come prepared, so I recall how I can solve this problem live there. So basically, I think you just want to find out if there's a path from the top, which is the root, to the leaf. You want to find the length of the longest path. So for example, like from here, 1, 2, 3. What is 1, 2, 3? So the maximum depth of this binary tree is 3. So I think it's a recursion problem. Then also has a depth there. So I think the common pattern I would do is like a depth helper function, and then you can take a rule, and this rule takes a tree node, takes an optional tree node. So I think optional means it can be none. And then you give a depth, which is an integer, and return an integer of it. And then let's pass for now. So in the main function, the main body of the function, probably can just like depth helper and a rule and give a 1. So that's probably it. But first of all, let's make sure the rule is not null. If the rule is null, that means it has no depth, then it's 0. But if the rule is not null, then we can call the helper and set a 1 to it and pass the rule to it, and this magic function will do the work for us. So inside this depth helper, so if like a rule is, well, I think the precondition is like if we call the depth helper, make sure it's not null. So I'm not gonna check if this rule is not or not. So if rule left is none and root right is none, that means this is a leaf node. Then we can just return the depth, not going any further. So that's like the recursion termination condition. And then next, it's like we're gonna compute the left depth. So let's say if root left probably can initialize the variable first to set them to 0. And if rule left is not null, then the left depth will be calling this depth helper root dot left. And then because it's one level down, so we're gonna increment the depth. So basically telling the root left, your current depth is the depth plus 1. And similarly for root right, is not known. So y depth equal to depth helper root dot right, and then depth plus 1. Then we have the depth of both from both sides. And here we can just return the maximum of the current depth. Actually, yeah. So we can just return the maximum of like left depth and the right depth. So that should work. All right, wish me luck. Go to run a small test. And again, so this is from the Trino type. Need to close by the square bracket. Yeah, pass the small test and the big test. Yeah, it passed the big test there. So to recap a little bit, this is like a typical DFS checking the depths. Usually I check the depths in a variable and then pass this variable. Whenever it goes to the next level, increase that by 1. And then if like for the main part of the function is pretty simple, just 3 lines of code, and let this magic function handles everything. But I kind of feel that we probably don't need like this ending part. So I'm going to take this challenge, like not implementing the helper, just use this function directly and see if this can be done there. So I'm going to delete everything for now. So let's say if root is none, then apparently it's 0. The depth is 0. And so if root, then root is not null, then we can initialize like left depth and right depth equal to 0 and 0. And then if root dot left is not known, then we can just like left depth equal to recursively call the depth function, have like root dot left self. Yeah, because it's calling this function, so I need a self here. Okay, that's good. And then if root dot right is not known, then right depth equal to self dot max depth root dot right. And then this function is gonna think like root dot left is the minimum number of depths there. It doesn't know anything about the tree on top of it. So the result will be like the current depth, which is 1, plus the max of like left depth and the right depth. So I think this should also work. Let me run. Yeah, it passed the small test and it passed the big test. So yeah, so I just tried like a two kind of method to implement the same thing. This solution looks like more clean. Doesn't need like an actual internal function to do the recursion. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.